All right, let's look at the variance and the standard deviation of exponential distribution. All right, so here's the exponential probability density function. Let's find the variance. All right, so variance is going to be, all right, so we have an integral from 0 to infinity, all right? And the expected value came out to be lambda, so I'm going to use lambda. So it's x minus lambda, right? So this is a square difference from the mean. Then you have to put the probability density times, so over lambda e to the negative x over lambda with respect to x. All right, then we're going to do integration by parts. Again, we actually have to do it twice. So we have, let's say, we're going to call this part right here u. And we're going to call this part, actually, I take that back. I'm going to actually take only this part, u, and everything else, dv. Right? So I think this is going to work out a little bit cleaner. All right, so we're going to let, so I'm going to do it here. Let u be quantity x minus lambda squared, and the dv to be 1 over lambda e to the negative x over lambda dx. Right? Then go through the usual drills. We take the derivative, so you have a du over dx is equal to 2 quantity x minus lambda, and derivative inside is 1, so times 1. So we have that. And then we can just simply multiply through by dx to get du. So du is 2 times quantity x minus lambda dx. All right, so this one we divide through by dx so that we can see that the dv over dx, which is the derivative, and then you have a 1 over lambda e to the negative x over lambda. All right, then we can simply take the antiderivative to find v. All right, so this is going to be so e to the negative x over lambda divide by negative 1 over lambda. So 1 over lambda and 1 over lambda cancel out, and so you just have a negative sign there. All right, so we need, let's see, we need u, and we need du, and we need dv to complete the integration by parts. All right, just the first iteration anyway. All right, so this is going to be, all right, so it's going to be uv, so it's going to be, there's a negative sign, and we have x minus lambda squared e to the negative x over lambda, and then you're going from 0 to infinity. All right, minus, right? So v du, so there's a negative sign, so I'm going to turn it into a positive sign, integral from 0 to infinity, right? Then you're going to have, so negative sign is already taken care of, so you have a 2 x minus lambda e to the negative x over lambda dx, right? So this is that, and then here. All right, same as last time, we're going to have to, as x goes to infinity, you're going to have to use the L'Hopital's rule, in this case twice, because it's got the square there, but still it's going to approach 0. Right, so it's going to be 0 minus. right? If you plug in 0, so there's a negative sign, so it's going to be plus sign, right? So you plug in 0, so it's a negative lambda squared, so it's going to be lambda squared, and e to the 0 is 1, so you just get that, right? Plus. All right, now we're going to have to do a second integration by parts, right? So this time I'm going to call this guy u, right? And then I'm going to call this guy, actually, I forgot to include dx here, this guy dv, right? So we're going to let this, so that's the second one. I should have used a different color maybe, right? U is equal to 2 x minus lambda, right? dv is equal to e to the negative x over lambda dx. All right, as usual, take the derivative. Du over dx is going to get you just 2. And then multiply through by dx. All right, so you have a du is equal to 2 dx. Right? And here, we're going to divide through by dx. We get dv over dx is equal to e to the negative x over lambda. All right, then we take the antiderivative with respect to x. We're going to get, let's see, v is equal to e to the negative x over lambda divided by negative 1 over lambda. So it's going to be multiplied by negative lambda. All right, we have that. All right, so we need u, and we need du, and also v. All right, so then we're going to go through this. All right, so uv, so maybe I have to, let's see, maybe I have to give a little bit more room here. All right, so let's see. So I'm going to clean this up as lambda squared, because we have that already. Oops, that's not what I want. All right, so lambda squared. All right, plus. All right, so you have a uv. So this times that. So it's a negative 2. Let's see, lambda x minus lambda. All right, e to the negative x over lambda. All right, from 0 to infinity. Hopefully I got that correctly. All right, minus integral from 0 to infinity. All right, there's a negative sign here, so it's going to be a positive sign. And then you have a 2 lambda e to the negative x over lambda, right, dx. All right, so we got that. All right, then let's evaluate this. All right, so just like before, if x goes to infinity, so this guy is going to be a huge denominator. It's going to go to 0. So you have lambda squared, and then if you plug in 0, right? So this is an interesting one. So minus minus, so this is going to be plus, right? And if you plug in 0, so you have let's see, 2 times lambda and times another lambda, so it's going to be negative, right? 2 lambda squared, right? And a plus. All right, and oh, actually a minus, I guess. All right, so minus, and if you plug in 0, so if you plug in 0, actually, well, sorry, I already done that. Sorry. So we have that. All right. Whoops. All right. So then you have to do this part. All right. So that's going to be. All right. Antiderivative of this guy is going to be, let's see, e to the negative x over lambda, and then multiply by, divide by negative 1 over lambda. So it's going to be negative 2 lambda squared. Right? Then going from 0 to infinity, right? So this is going to be lambda squared minus 2 lambda squared. Right? If you plug in infinity here, so it's going to go to 0. So it's going to be plus 0 minus, and then is a negative sign, so it's going to be plus. If you plug in 0, it's going to be 1, so you have a 2 lambda squared. So we can cancel negative 2 lambda squared and 2 lambda squared, so you are left with lambda squared, right? So variation is that lambda squared, so which is equal to sigma squared. So therefore, standard deviation, sigma, is actually same as lambda as well, right? So when you have exponential distribution, the mean or expected value is lambda, and the variance is lambda squared, and the standard deviation is actually lambda as well. So it's very easy to remember. It's pretty much all lambda. All right, that's it. I hope that this was clear.